KZN Grade 10 November 2023, and this is paper 1. So for question 1, we're given this expression for t. It says t is equal to the square root of x plus 5 divided by x minus 1, and we're told that x is a number from this set, minus 6, minus 2, 1, or 4. And then in the question, we're asked to give from the set of numbers a value of x which will satisfy these two things. So for the first one, we want the values of x out of these numbers, which will give us a rational expression for t. So for t to be rational, I know that my rational numbers do not have decimal points that go on forever and ever and ever, and they don't have a definite pattern to them. So like pi is an irrational number, it's 3.14, so on and so forth, but there's no definite pattern to the numbers. And I know that I will definitely have irrational numbers when I've got the square root of something that isn't a perfect square. So I see this square root as part of the expression for t. So I know that if I put in a number for x, which is not a perfect square, then I will get the square root is going to be an irrational number, and no matter what the denominator is, when this irrational number is divided by this denominator, it's still going to be irrational. So for x, I'm just looking for numbers that, when added to 5, do not give me a perfect square. So when x is negative 6, I have that x plus 5 is equal to negative 1, and the square root of negative 1 is not even a real number. And since rational numbers have to be real, I can eliminate x equals negative 6. Then again, when x is equal to negative 2, I'm going to have that x plus 5 is equal to 3, and 3 is not a perfect square, so the square root is going to be irrational. Then I've got x equal to 1, and when x is added to 5, it's going to be 6. The square root of 6 is 6 is not a perfect square, so the square root of 6 is going to be irrational. And then finally, I've got x equals to 4. So when x is added to 5, I'm going to have 9. That is a perfect square. And so the square root of 9 is going to be 3. And then I'm going to put 4 in the denominator, and 4 minus 1 is 3, so my answer is going to be 1. So when x is equal to 4 is the only time that I don't end up with any rational expression for t. So my first one is going to be x equals 4. And then for 1.1.2, I want the values of x for which the expression is non-real. And remember when we had x being negative 6, here in the denominator, I would have had square root of negative 1, and that would give me a non-real number. And that doesn't happen for any of the rest of them. It's only when the square root is of a negative number. So for my non-real values of x, that is when x is equal to negative 6 only. Then part 1.2, we're asked to factorize the following expressions. So for 1.2.1, I'm given 3x minus x squared. And I can see that I have a common factor x in each of these terms, so I'm going to take out the common x. And then I have a bracket, and the first term left in the bracket is going to be 3, and the second term left in the bracket is going to be x. And if you're not sure, you can you can multiply the x back in to each term in the bracket, and you'll see that you'll get exactly what you started with here. Then for 1.2.2, I've got y minus xy plus x minus 1. And to factorize these, I'm going to want to group some terms. So I'm first going to rewrite this expression and put the terms that I want to group next to each other. So I want to group these two, and then I want to group these two. So I'm going to keep y at the front. I'm going to bring negative 1 next to it. And then I've got negative xy plus x. So the first two terms I'm going to keep the same and put them in a bracket. And then with my next two terms, I want to try and get a bracket that looks exactly like this one. So if I've got this negative xy and a positive x, and I take out a common negative x from both of them, I'm going to be left with a positive y for the first term, like I have here, and then I'm going to be left with a negative 1 for the second term, like I've got here. So I'm taking out a common negative x. What's left here is positive y, and what's left here is negative 1. So now I can see that my brackets are the same, and I do the final step of my factorization. So I'm taking out this common bracket, y minus 1, from this term and from this term. So when I take out y minus 1 from the first term, I'm just left with 1. And when I take it out of the second term, I'm left with negative x. So the 1 and the negative x is going to make up its own bracket. So I'll have this, and that's being multiplied by this. And if you want to double check your answer, you can just use FOIL and multiply these two brackets together and see if you get back to either this expression or this expression. Remember, they were the same, we just rearranged them. So by FOIL, I'm going to multiply these two brackets. So the first two terms multiplied together is y times 1, which is y. Then the outer ones multiplied together is y times negative x. So that's negative xy. Then the inner ones multiplied together is negative 1 times 1. So that's negative 1. And then the last ones multiplied together are negative 1 and negative x, so positive x. And we can see that that's exactly what I had. Then 1.3, we're asked to simplify the following. So for the first one, I have x plus 3 and x squared minus 3x plus 9. So to simplify, I'm going to multiply every term in the first bracket by every term in the second bracket. So I'm going to have x times all of these, and then I'm going to have y times all of these, and then I'm going to collect my like terms. So first, multiplying x by everything in the second bracket, I have x times x squared is x cubed, and then x times minus 3x is minus 3x squared, and x times 9 is plus 9x. And now multiplying 3 by everything in the second bracket. So for the first one, I have 3 times x squared, which is 3x squared. And then for the next term, I've got 3 times negative 3x, which is negative 9x. And then for the last one, I've got 3 times 9, which is positive 27. And now I'm looking at my like terms, and I can see that I can cancel out some stuff. So I've got a minus 3x squared and a positive 3x squared. When I add them together, I get 0. And the same with this positive 9x minus 9x, I get 0. And so I'm just left with these two terms, x cubed plus 27. Then for 1.3.2, I'm given these fractions. So since I'm being asked to simplify these expressions, I know that I want to get all of these fractions into one fraction by having a common denominator. Then I'm going to be able to add and subtract my numerators normally. So the first thing I want to do is factorize all of these denominators so that I can see how I can make them into a common denominator. So for the first one, I've got x cubed minus 1. And I can recognize that I can use the difference of 2 cubes. And the difference of 2 cubes says that if I've got 2 perfect cubes, so x cubed is a perfect cube and minus 1 is a perfect cube, then I'm going to have this one bracket becoming 2 brackets. And in my first bracket, I'm going to have the cube root of the first term. So the cube root of x cubed is x. And then I'm going to have the cube root of the second term, which is the cube root of minus 1, which is minus 1. And then for my second bracket, I'm going to square the first term of the first bracket. So I'm going to have x squared, which is x squared. And then for the second term in my second bracket, I'm going to have the two terms multiplied together from the first bracket and a difference in sign from the first bracket. So I'm going to have 1 times x, which is x as this term. And then my sign for this term is going to be the opposite sign of what I have in the first bracket. So instead of having negative, I'm going to have a positive here. And then for my last term in the second bracket, I'm going to have the second term of the first bracket squared. So minus 1 squared is positive 1. Okay, that's my denominator for the first one, and my numerator stays the same. Then for the next one, this is the difference of two squares, because I've got 1 which is a perfect square and minus x squared which is a perfect square. So I'm going to have two brackets again, and the first term in both of the brackets is going to be the square root of the first term in the original expression. So I'm going to have the square root of 1 for both. Then one of them is going to be positive, the other one is going to be negative. And then for the last term in both brackets, I'm going to have the square root of this term from the original expression. So for both of them, I'm going to have the square root of x squared, which is x. And my denominator stays, the numerator stays the same. And then for the last one, I've got the difference of two squares again. So this time I'm going to have x minus 1 and x plus 1 in the denominator, and my numerator stays the same. Then for my next step, before I want to continue with getting a common denominator, I see that I can simplify all of these fractions and make them easier to work with. So for the last one, I can see that I've got an x plus 1 here at the top, and I've got a bracket of x plus 1 at the bottom. So I can cancel these two out, and then I'm just going to be left with 1 over x minus 1. With the second fraction, I see that I've got 2x plus 2, and that means I've got a common factor of 2 across both of the terms, so I can take out this common 2, and I'll have x plus 1. And x plus 1 is exactly equal to 1 plus x, so I can cancel out these two. And I'm just going to be left with 2 at the top, and this is cancelled, and x minus 1 at the bottom. And then in the first fraction, for the numerator, I can see that I've got a common factor of x in each of the terms. So I'm going to take out a common x, and for the first term I'm left with x squared, for the second term I'm left with just x, and then for the last one I'm left with 1, which means that this bracket can cancel out with this bracket, and I'm just left with x at the top and x minus 1 at the bottom. So I'm taking out a common x here. And my denominator stays the same. And then these two cancel out. Then for the next one, I took out a common 2. I'm left with x plus 1. And then here I've got 1 plus x and 1 minus x. And these two cancel out. And then for the last one, it stays the same. But then these two cancel out. So I'm left with the 1 here. Okay, so I'm going to rewrite these simplified. So for the first one, I just have x over x minus 1. For the next one, I just have 2 over 1 minus x. And for the last one, I just have 1 over x minus 1. So now I almost have my common denominator. These two are fine. It's x minus 1 and x minus 1. But this one is kind of the wrong way around. right? So I've got a negative x here, but then for these two, it's a positive x and a positive x. And then for this one, I've got positive 1, but for these two, it's negative 1 and negative 1. So I want to make this denominator look exactly like these two. And I can do that by taking out a common factor of negative 1 from these two terms. So when I take out that common negative 1, my sign here is going to change to be a negative, and then I'm going to be left with positive x at the bottom and negative 1 at the bottom. So the first one stays the same. My sign is changing for the whole fraction. It's now negative. 2 stays the same, and I'm swapping the signs of the terms that were at the bottom. So where I had negative x, I'm now going to have positive x. And where I had positive 1, I'm now going to have negative 1. And the last one stays the same. And now that I've got a common denominator, I can just put everything over that one denominator, and then I can add and subtract my numerators. So for my numerators, I'm going to have x minus 2 plus 1 all over x minus 1. And at the top, I can group my like terms. So minus 2 plus 1 is minus 1. So I just have x minus 1 over x minus 1. And these two cancel out. Or anything that's over itself is equal to 1. So my final answer is 1. And then the final part, 1.3.3. I have just one fraction now with expressions of x as my exponents. Okay, so the first thing that I notice is all of my bases are different. So for this one, I've got a base 10, for this one, I've got base 4, and for this one, I've got base 25. And if I want to use my exponent laws, I know that I probably want my bases to be the same. And when the bases are the same and things are being multiplied and divided, then I can just add and subtract the exponents. So I want to make all of my bases look the same. And I can do that by using the products of prime factors. So given the numbers that I've got here, I've got 10, I've got 25, and I've got 4. It looks like the bases that I want are going to be 2 and 5. So for all of these bases, 10, 4, and 25, I'm going to try and write them in terms of 2 and 5. So for 10, in terms of 2 and 5, I'm going to have 2 times 5. And then the exponent remains the same. For 4, I'm going to have 2 times 2, or 2 squared. And the exponent stays the same. And then for 25, I have 5 times 5, or 5 squared. Okay, and then I know that when I've got numbers being multiplied together in one bracket, and that product is raised to an exponent, then this exponent belongs to each of the numbers in the product. So I'm going to have 2 raised to this exponent multiplied by 5 raised to the same exponent. And then for these ones that have got the squares, I know that when I have a number that is raised to an exponent and then raised to another exponent, all that means is that I can multiply these exponents together. So I'm going to have 2 to the power of 2 times 1 minus x, and then I'm going to have 5 to the power of 2 times 2 plus x. So for the first one, I'm just giving each of these numbers in the product the exponents, and they're still multiplying each other. And then for this one, I'm just multiplying 2 times 1 minus x. And I do the same in the denominator. So this is now 4 plus 2x. All right, and then I can now use my exponent laws. So my exponent laws tell me that if I've got some kind of an expression in the exponents, then that means that that's the same as having this base to the power of one of the terms multiplied by the same base to the power of the other terms. So I'm going to have 2 raised to 2x multiplied by the same base 2 raised to 3, and that's the same for all of the rest of these. So for this one, I'm going to have 5 to the 2x multiplied by 5 to the 3, and then for this one, it's going to be 2 to the 2 multiplied by 2 to the minus 2x, and then 5 to the 4 multiplied by 5 to the 2x. Okay, and now I can just, since everything is being multiplied by each other, I can just add the exponents which have common bases. So for my base 2 ones, I'm going to have this base 2 raised to the power of this, plus this, plus this, plus this. And then for the 5s, I'm going to have base 5 raised to the power of this, plus this, plus this. And now for my 5s in the denominator, I know that when I have 2 numbers that are being divided, which are the same base, I subtract the exponents. So the 5 is going to be raised to this one, plus this one, plus this one. But now for the ones that are in the denominator, I'm going to have negative exponents. So I'm going to have minus 4 and minus 2x. So I'm going to group my bases accordingly. So base 2, and I'm adding up all the exponents. So I have 2x plus 3 plus 2 plus minus 2x is minus 2x. And then that's being multiplied by the base 5 ones. So I have 2x plus 3, and then the ones in the denominator are going to be negative. So this is minus 4 minus 2x. Then in my exponents, I want to group the like terms. So I see that this 2x cancels out with this minus 2x, because 2x minus 2x is 0. And that's going to be the same for the base 5. And then I can just add the numbers that are in my exponents. So I'm going to have 2 raised to 3 plus 2, which is 5, multiplied by 5 raised to 3 minus 4, which is minus 1. And I know that anything to the minus 1 just means 1 over that number. So this is going to be 1 over 5. And I know that 2 to the power of 5 is 32. So my final answer is just 32 over 5. 1.4, I'm asked to determine the numerical value of 3 plus y all squared if it's given that 9x squared plus y squared is equal to 12 and xy is equal to minus 3. So the first thing I'm going to do is expand this bracket here. So if I have 3x plus y squared, so I have a bracket that has 2 terms and it's being raised to the 2. So I can use my trick. I just square the first term, square the last term, and I multiply these 2 together and times them by 2. So for the first bit, I'm going to have 3x squared, or 3x all squared, which is 9x squared. Then I multiply the 2 together and times by 2, so 3x times y is 3xy times 2 is 6xy. And then I'm squaring the last term, which is y squared. And you could also do this by just multiplying this bracket by itself. So 3xy squared is the same, 3x plus y squared is the same as 3x plus y times 3x plus y. And then you just use FOIL, so the first 2 multiplied together is 9x squared. The inner 2 multiplied together, the outer 2 multiplied together is 3xy. The inner 2 multiplied together is 3xy. And the last 2 multiplied together is y squared. And then I group my like terms. So I got 9x squared, and I've got 3xy and 3xy, so it's 6xy. and then y squared. So you can see that you get the exact same answer here, whichever way you do it. Okay, so now I've got this fully expanded, which is equal to that. Then in the question, I was told that 9x plus y squared is equal to 12, and xy is equal to minus 3. So everywhere that I see 9x squared plus y squared, I can write 12, and everywhere that I see xy, I can write minus 3. So I'm going to rearrange this expression to bring the y squared near the 9x squared, so it looks like this. And then I just have 6xy. So now that this looks like this, I'm told that I can write 12 instead of writing 9x squared plus y squared. So I'm substituting this for 12. And then I'm told that everywhere that I see xy, I'm going to write minus 3 instead. So here where I have 6 times xy, I'm not going to write xy, I'm going to write minus 3. Then this is 12 minus 18, and that is minus 6. Okay, and now question 2. For the first part, 2.1, we're asked to solve for x without using a calculator. So for the first one, 2.1, we're given this expression. Okay, I'm going to bring this 3 to the left-hand side, so it becomes a negative 3, and then on the right-hand side, I'm just going to be left with 0. And now I'm going to factorize the left-hand side, so I'm going to have 2 brackets, which is equal to 0, and given that the first term was 2x squared, I know that my first term in these 2 brackets multiplied together have to give me 2x squared. And I can have that if the one of them is 2x and the other one is x squared. Just x. And then I see that my constant term is minus 3, which means that this one and this one multiplied together need to give me minus 3. So I know it's definitely going to be 1 times 3, but I'm not sure about the signs yet, because I know that one of them has to be positive and the other one has to be negative. But then I also know that these 2 terms, when I multiply the inner ones together and I multiply the outer ones together, are both going to have terms of x, and when I add them together, I want it to be minus 5x. So if I want this to be a negative 5x, that means that I should have negative 6 as these 2 being multiplied together, plus 1 to get me to negative 5. Right, so I want my 6 to be the negative 1, which means that this 3 must be negative. Then I put a positive here, and then I have positive 1. And you can check that you've done that correctly by FOIL. So I'm just multiplying everything together again. So the first times the first is 2x squared. The outer times the outer is minus 3 times 2x is minus 6x. The inner ones is 1 times x, which is positive x. And then the last ones is negative 1 times 1, which is negative 3. And that simplifies to 2x squared minus 5x minus 3, which is what I wanted. Okay, then we continue to solve for x. So if I've got these 2 brackets multiplied together and the answer is 0, that means that either this bracket is equal to 0 or this bracket is equal to 0. Right, so if the first bracket's equal to 0, that means 2x plus 1 equals 0. And the second one is x minus 3 equals 0. Now I'm going to solve for x in both brackets. So for this one, I'm going to take the 1 over to the other side. It becomes a negative 1, and then I'm left with 2x on this side. And to get x on its own on the left-hand side, I'm going to divide it by 2, which means that I have to divide the right-hand side by 2 as well. So remember, we had negative 1 here, and that's going to be divided by 2. So on the left-hand side, I'm just left with x, and on the right-hand side, I'm left with negative 1 over 2. And then for this one, all I have to do is take this minus 3 over to the other side. It becomes positive. Then on the left-hand side, I'm just left with x, and on the right-hand side, I'm left with positive 3. And then 2.1.2, we're given this fraction that's raised to an exponent with x in it, equal to 128. So the first thing that I want to do on the left-hand side is get rid of this fraction. So we know that if I've got 1 over 2 and 2 is in the denominator, that's the same as 2 being raised to the power of negative 1. So I'm going to rewrite this 1 over 2 as 2 to the minus 1, and it's still to the same exponent. Then on the left-hand side, I want it to be in exponent form as well. I want a base with an exponent, and I want the base to match the base that's on this side so that I can use my exponent laws. So I want it to be base 2, and I know that 2 raised to the power of 7 is 128. Now I can multiply this exponent into this expression. So I'm going to have minus 1 times 3x is minus 3x, and then minus 1 times minus 1 is positive 1. And then again, this 2 being raised to this expression is the same as having 2 being raised to the first term in the expression multiplied by the same base 2 being raised by the other term in the expression. So I can write it like this. And 2 to the 1 is just 2. Then I can take this 2 over to the other side by dividing by 2. So that would be like having 2 over 7 over 2, 2 to the 7 over 2 to the 1. And I know I can cancel this out, and I'm going to have minus 1 for this exponent. So I'm left with 2 to the 6 on the right-hand side. And then I'm left with the base that has an x in it in its exponent on the left-hand side. So I have 2 to the minus 3x is equal to 2 to the 6. Now I've got these same bases, 2 to the, this one is 2 to the minus 3x, and this one is 2 to the 6. And if these are equal, then that means that the exponents are equal. So minus 3x is equal to 6. And I'm just going to divide both sides by minus 3. So on the left-hand side, I'm left with x on its own. And on the right-hand side, 6 divided by minus 3 is minus 2. And then 2.2, we're given this inequality. And we're asked to solve for x, and we're told that x is a real number. Okay, so when I have an inequality, I'm going to solve it in the same way as I would as just a regular equation, except that everything that I do in the middle here, I'm going to do on this side, and I'm going to do on this side. So for the first step, I want to get 3x on its own, so I'm going to add a positive 2 to the middle, which means that I'm adding a positive 2 to the right-hand side, and I'm adding a positive 2 to the left-hand side. So on the left-hand side, I add a positive 2, and I'm left with minus 3. In the middle, I add a positive 2, and those two cancel out. Minus 2 plus 2 is 0, so I'm just left with 3x. And then on the right-hand side, I'm also going to add a positive 2, so I have 9. And then to get x on its own, I'm going to divide the middle by 3. Right, I divide the middle by 3, which means that I must do the same on either side of it. So on the left-hand side, I'm going to divide by 3 as well. I'm left with negative 1. And on the right-hand side, I'm dividing by 3, and I'm left with 3. So this is negative 1. In the middle, I'm left with x. And on the left, I have 9 over 3, which is 3. So x is a number between minus 1 including and 3 excluding. And then for the last part of question 2, we have 2.3, and we're given these two equations. And we're asked to solve for x and y simultaneously. So what I want to do is, from this first equation, I'm going to call it equation 1, and I'm going to call this one equation 2. I'm going to get an expression for y in terms of x. So I'm going to have a y equals something with x in it, and then I'm going to substitute in this value for y into equation 2. Then in equation 2, I'm only going to have x's, which I'm going to simplify the equation, and then get all of my x's on one side equal to the numbers on the other side. Then I can solve for x. Then I take that value of x and I substitute it back into either equation 1 or equation 2, and I'm going to find my value for y. So my first step is going to be writing equation 1 in terms of as y equals something with x in it. So to do this, I want my y to be positive, so I'm going to take it over to this side and I'll have positive y. And then I only want y on that side, so I'm going to take the 17 to the left-hand side, and the positive 17 is going to become a negative 17. So I'll have this. Okay, and now that I've got an expression for y in terms of x, which is that, I'm going to substitute this into equation 2. So everywhere in equation 2 that I see y, I'm not going to write y, I'm going to write 2x minus 17. So I am subbing y equals 2x minus 17 into equation 2. And I get 2x minus 17, and everything else stays the same. Then I'm going to distribute the 4, so 4 times 2x is 8x, and 4 times minus 17 is minus 68, and everything else stays the same. Now I want all of my x's on the left-hand side, and I want all of my numbers on the right-hand side. So on the left-hand side, I'm going to have 8x plus 3x is 11x. And then on the right-hand side, I have 9, and I'm going to take the negative 68 over to the other side. So that negative 68 becomes a positive 68, and 9 plus 68 is 77. So that means that x is equal to 7. Now I have my value for x, which I can substitute into either one of these two original equations, and I'll get a value for y. So I'm going to sub x equals 7 into equation 1. So everywhere that I see x, I'm not going to write x, I'm going to write 7. And we can just solve this. And if you want to make double sure, you can also sub x equals 7 into equation 2. So same thing, everywhere that I see x, I'm not going to write x, I'm going to write 7. So I have 4y plus 3 times 7 is equal to 9. And we just simplify. So we get the exact same answer.